If you can get more of your product fleshed out before you build prototypes, you waste a lot less time and money and materials when designing it because you don't have to build and scrap as many parts. So when being able to test things in a large scale in the digital realm, it helps reduce the waste of material.
Welcome to another episode of the Next Generation Design Podcast. I'm your host, Jennifer Piper. Today, we're really living up to our name and talking quite literally to a next generation designer. In this episode, I welcome Leah Griesmer, a third-year mechanical engineering student at the University of Cincinnati, where she's chapter vice president of the Society of Women Engineers. Leah has interests in additive manufacturing and 3D modeling, and also has goals to go into product design after graduation. Thanks to Siemens' partnership with the University of Cincinnati, she was able to learn NX in the classroom. Before we begin today, let's meet our guest. Leah, would you like to tell our listeners a little bit about yourself?
Hello, everyone. Currently, I am on co-op at True Automation on our product development team, working on conveyor belt design systems. Outside of my co-op, I've had a lot of design experience in high school through my engineering CAD classes in Vex Robotics. And I am currently going into my third year of mechanical engineering.
Thanks, Leah, and welcome to the podcast. Thank you for joining us today. I'd like to start with a little bit about your background. How did you realize you wanted to get into product design?
My high school had a lot of STEM classes, and one of them was my engineering CAD class, where we were given different design prompts, and we would have to go and design. This wasn't necessarily product-wise, but we just would design like little balsa wood bridges or airplanes or sumo cars, and I was always very fascinated with the design process. As a result of that, I joined my high school robotics team, where I had to design robots every year to face off in different games. Each game had its own unique problems you had to solve, whether it be shooting balls with a catapult or stacking cubes up like 3 feet in the air. So engineering definitely was an interest for me. So I decided to go into mechanical engineering, as it was a very diverse major and I wasn't entirely sure what I wanted to do. And then I saw a co-op position at a product design team where I could use a lot of CAD, which is something I've enjoyed doing since high school. And I joined the product development team at True, and I've been having a wonderful experience ever since.
Did you know in high school that product design was something you wanted to pursue further academically and professionally, or did that come later?
I don't know if necessarily product design, but something with engineering. I've always been very hands-on, even from like a young age. I would do like Lego Mindstorm camps at my local library. And my city had a summer camp called Camp Invention, where people around the community would donate old parts of things, and then we would just build random Rube Goldberg machines. And so I've always been very into tinkering and designing.
So how would you say your UC coursework so far has prepared you to pursue a career in product design?
Other than my basic math and science classes, UC has a freshman engineering course called ENED, and as part of that, we had a project where we had to pick some sort of not necessarily humanitarian problem, nothing on that large of scale, but something local. So my group picked homeless people, and a big issue they had was having comfortable sleeping accommodations. And so we worked on designing a memory foam portable sleeping bag to help with back pain when having to sleep outdoors. In another class I took, I learned all about NX in my 3D foundations class, where we had to take apart and reverse engineer it. So we would like take a Nerf gun, for example, and we took it apart, measured out everything, redesigned it, and modeled it up into the 3D realm. And since I've only had 2 years of classes, I haven't had much more design work from that. But I do know my senior year, I'll have my senior capstone project, which will be a full-on product design experience.
Can you tell me a little bit more about the sleeping bag project? Were you able to actually produce those?
Yeah, normally we would have produced it, but unfortunately my freshman year was in 2020, which was the peak of COVID, and so we didn't have in-person classes. And so we built a small prototype, but we weren't able to really work together and collaborate because we were in isolation. But We did build like a small prototype and we had various people come and test it out, but we weren't able to get the materials we wanted to do a full scale project.
Understandable, but what a great project with so much value. I'd like to switch gears a bit and talk about some of the design experience that you've had. Can you walk me through what that process is like when you're designing a product? Where do you start?
The most important thing is to start off by talking to whoever hired you or who's giving you the idea for it and figure out what their goal is, like what the overarching problem is that you're trying to solve. From there, you want to go and find out what specific design specifications there are to solve that problem, like how big does it need to be, what type of materials, does it need to be waterproof, what are your cost restrictions, what different type of materials can you use, all that sorts of stuff. So that way you're designing a product that fits their needs, but also doing it as efficiently and cost effective within their budget. After that, I will go and start into the brainstorming phase. So I will sketch up or 3D model different concepts, talk to whoever's in charge of the final design, get their input, and redesign it from there.
And is there a way of making the process easier or more intuitive along the way?
The use of 3D modeling is incredibly helpful because I'm a very multi-dimensional thinker. I'm not the best at quite sketching things out after the initial design. So being able to physically mold the product digitally and look at it in different views, be able to put it, if it's a component, like on my conveyor belt team, there's lots of different components. So we can put it in on the conveyor belt, see how it looks in the digital realm. We can work out a lot of the kinks before we physically produce it. So that way, when we have a final product, there's less refinement to do. So I would say definitely having the opportunity to mock it up in the digital realm is extremely useful.
What would you say are some of the benefits of working with software in order to create digital mock-ups?
There are tons of amazing softwares out there. Personally, I've had a ton of work with SolidWorks, Fusion 360, and Siemens NX. A lot of those softwares not only allow you to 3D model the product you're building, but they also let you run like stress analysis tests, determine how much it's going to weigh. If it's a mechanical component, you can put all the pieces together in assembly and run animations of how they'll go together while they're moving. And then you can find weak points within your assembly before you even go and start to build it, which really helps in prototyping design phases, because by the time you finally get your parts, the lead time is usually about a month for everything, if not more in the current industry. And so if you can work everything out before you're getting your prototype pieces, the prototype will be as close as it can to the final and overall model, which will save a ton of money and a lot of time.
You mentioned at the start of our conversation that you're involved in a co-op program. Can you tell us a bit more about that experience?
I'm on my second term co-op with True Automation, which is a conveyor belt company. I'm at their Fairfield office, but their headquarters are in Milwaukee. With my co-op experience, we're currently designing various different types of conveyor belts. So right now we're working on a V-belt conveyor where it's just like a skinny little trapezoidal belt. So as part of that, I'm working on designing the drive. And so my boss tells me it needs to have this horsepower, it needs to have this components in it, and he gives me all the different design specifications. And then I'm going in and designing all the different components, testing them out, seeing how they work together, building safety guards, and all that stuff. And then from there, it'll be attached to curved or straight or spiral conveyors.
And have you had much experience working on the electronic side of things?
I've done a little bit of programming, but not too much. In my freshman year of college, I did a Lego Mindstorm project, but unfortunately, due to COVID, we had to do it digitally. So I was working with the different sensors, but we were just programming them into like theoretical sensors. But I still kind of learned how to put on. We had our project, we had to design a robot that would go and pick up different materials of shredded matter, and you would have to sort it based off of its overall weight and density. So it would be in the same volume container, so we could weigh it and figure out what material it was. And then based off of that, it had to follow a broken line and drop it off at different locations. So we were using a bunch of different sensors. The biggest one was the line sensor. So we programmed it to, as long as it wasn't seeing the black line, it would go straight. And then if the top or bottom sensor would see it, it would turn accordingly so it could follow the path. So I had a little bit of experience that way, but with the mechanical side, I haven't had much other electronic design.
Now, you mentioned before that you had some experience working with Siemens product NX. Can you tell us a little bit about your experience using that software? Were you using it on the cloud or were you using the desktop version?
I had a download on my personal laptop, and then I just submitted files to my professor, but I did use it in a classroom setting. I picked it up very quickly, but I did have some 3D modeling experience beforehand. I learned Fusion 360 in high school, and I found switching between that and NX was almost seamless. I really just had to learn where all the different buttons were, but it was really quick and easy to learn. I ended up designing. We took apart like a Nerf gun, as I mentioned before, for our final project, and we had to look at all the mechanical parts and design them and then put it back into an assembly and show how it moved. It was a great experience, and I was able to easily share files with my teammates, and we could like work together to make one final overall assembly.
What types of materials were you using to learn it? Or were you just using it and you just picked it up because of your experience using CAD software?
I pretty much picked it up seamlessly. I did have a textbook. I cannot remember the name of it, but it had all sorts of materials. Also just learning the standard like dimensioning and tolerances used in the industry, it was really helpful for, but it did have a lot of like detailed instructions. But when I did learn 3D modeling, YouTube was an amazing resource. You could learn a lot from that and just the internet, watching different videos and learning how to explain it. But I also had an amazing professor that was really good at explaining it. And I would go to his digital office hours if I had any questions.
How would you say that NX software benefited your design process?
It had a lot of CAE capabilities. So we were able to run some like stress analysis tests. In a different product I was doing earlier on when we were exploring motors, we were able to like see how much stress was going on the overall fixture of the motor, depending on how much torque it was using. And that was really fascinating to learn because I'd never run any tests like that before. And I wasn't really sure how to quite go about it. And it was really easy because we could just plug it into the computer and it would give us all sorts of results.
Can you offer any constructive criticism for the software?
No, I really can't say much. Just because I haven't had like a super, super large in-depth time because I've only been like 3D modeling for about 5 years. But it was definitely very easy to learn. I was able to build like everything that I was working on with it. And I would have used it more, but my company is like a SolidWorks company. But I think it's a great program.
As someone trying to learn NX myself, I'm wondering if you have any advice for someone trying to get into product design or just CAD in general.
When I learned 3D modeling back in high school, we first started off by drawing everything in the two-dimensional area. So we did like just basic drawings, like, oh, my teacher would give us a picture with dimensions and we would draw it. But the first like physical product I designed was a balsa wood bridge, and we had to design a bridge that could withstand as much pressure as possible. So it would pull on a channel like this, and you'd see how much it could hold before it broke. So we did that one by drawing everything up two-dimensionally and then building the pieces. And wood is a very block type part, so it really helps like visualizing how to do it. And then from there, our next product, we got into 3D modeling and doing different shapes from that. But it's a lot about thinking, if you're going to look at a view two-dimensionally, to get that very first sketch, and then using your 3D modeling tools like extrusions, cuts, sweeps to make your overall final product and kind of shaping it off of the two-dimensional to make the three-dimensional. I'm not a great artist at all, which is why I love AutoCAD and all sorts of like two-dimensional things, because I cannot draw to save my life. But in a digital realm, I could like make and draw the shapes using the different lines, tools, and relations to make everything the way I want it.
Well then, maybe there's hope for all of us yet in our quest to learn NX. Leah, as you know, our podcast is called Next Generation Design. I'd like to know, where do you see the future of design headed?
I definitely think there's a lot out there we haven't even thought of yet. Like if you would have talked to me when I was in elementary school and you would have told me like I would be 3D modeling robots and all that stuff, I would have said you were crazy. So there's definitely a lot of future implementations. I know one of my friends at Siemens is actually working on nano 3D modeling softwares, which I thought is really cool because you can start to design things at like a molecular level.
It's pretty incredible to realize how far we've come in a rather short period of time. Continuing that thought, how do you see AI or artificial intelligence and machine learning coming into play in the future?
I definitely think AI will be a very big component in future designing. However, it can only go so far because it's really hard to teach a computer to think creatively. So I think it can be really effective in running tests and analyses. Like you can give it a part and say, hey, I want you to go and test this out and do whatever you need to do. And then it can come back. So you don't have to spend your time doing that. But I think the base design process will never get fully automated. However, AI is super effective in manufacturing because there's all sorts of like robotic manufacturing for bending and laser cutting out steel parts. Injection molding is really good for automation, which will help get the products out once they're designed. And it's allowing us to find more innovative ways to design products instead of being stuck to just basic manufacturing processes when you have more flexibility in the way the parts design.
And how do you see the sustainability component going forward?
I definitely think sustainability is a very important part, whether it comes to finding different materials that are more sustainable, finding manufacturing processes that are faster and have less scrap, but also, as I kind of touched on earlier, if you can get more of your product fleshed out before you build prototypes, you waste a lot less time and money and materials when designing it because you don't have to build and scrap as many parts. So when being able to test things in a large scale in the digital realm, it helps reduce the waste of material.
In the grand scheme of things, that reduction in waste could be an incredible benefit. Finally, Leah, looking forward, where do you see product design taking you in your future?
I have definitely had some good experience with project management. I was kind of a team leader in high school, and then I had a class in product management in my freshman year at UC. So leading like a product design team, it would be much further on in my career. I'd probably start out more on just a development team and then go from there. But I think that would be something I'd be interested in.
What's your dream job when you graduate college?
I would love to work at a toy company, product designing toys for kids. I think it would be so fun because it's such an imaginative role, but you can also get super complex with the design, which is not like completely automated, but just like all the different mechanical components, like even just a little toy fire truck, you can add all sorts of fun stuff with that. So I feel like that'd be a really cool position to get into.
Thank you so much to Leah for joining us today. We wish you luck in all of your future endeavors. Thanks also to our listeners for tuning in to today's episode. Join us next time for more discussions about the latest in design innovation and software applications. I'm your host, Jennifer Piper, and this has been Next Generation Design.